So in the next earlier class, we had discussed about the NumPy array. And in the NumPy array, we see that NumPy is one of the library function of Python. And in the last class, what I had discussed is the creation of matrix and using the NumPy, the range function, the zero function, the line space function, and the NumPy with the diagonal value 1, right? We also use the various random method, the property of random method. We had also discussed the range method, the reshaping of array, and so on. So what we had stuck over there is one of the that to convert a matrix into an array. Now, this is an NumPy array which is a simple matrix, and the matrix is then printed, the first one. In the second one, I have to convert this matrix into a one-dimensional array. Whenever a matrix is converted into an array, if we want to convert a matrix into an array, we have to use one of the method called flatten. This flatten method converts the matrix into an array. So this is the matrix over here, that is np.array. The array, this function that carries the matrix, and the matrix is defined by ARR. Now I want to convert this matrix into the single dimension or one dimensional array. And then in that way, in that respect, I have to use a method named flatten. So this flatten method converts this matrix into a one-dimensional array. So this, we had discussed the NumPy. I had also discussed the range function, the 10 numbers which can be taken from randomly from 0 to 50, right? I had discussed these things. And I also discussed the reshaping function.
Yes.
Right. Then I had also discussed the maximum value and the minimum value of the two numbers from the NumPy array. Right. Now, today what I had also give you a brief introduction regarding the machine learning, and one of that is the regression analysis, right?
Yes, sir.
So in the regression analysis, what we had discussed, that we discuss about the regression function, that is y is equal to the linear, do you know the equation of the linear regression I had discussed? You know that what is the linear and what is the linear equation? Y is equal to beta 0 plus beta naught x plus epsilon. This is the linear equation of simple linear regression equational model, right?
So স্ক্রিনটা তো আপনার ফিক্সড হয়ে আছে।
Is it visible now?
Yes, sir, it is.
Hmm. So this is the linear regression equation, right? So
Sir, please repeat this.
just a minute. Now we had discussed the introduction of what is the regression. There are various machine learning model, and one of the model is regression. Now what is regression? Regression means estimation or the prediction, right? The estimated value which is compared with the actual value, the estimate the predicted value which is compared with the actual value. So regression is basically means estimation. We have to, certain data will be given to us. Our data set, in the data set, certain data will be given to us. With that respect, with the use of those data, I have to establish the model. I have to establish an algorithm, and I will then at the end, I will analyze, I will visualize that particular algorithm using the various matplotlib or various or the seaborn analysis by which we can see that whether the data set, how the data set are arranged and how they are visualized with the help of the seaborn and the matplotlib library function. We can see, we can visualize the data model. After that, what we will do, we will analyze our model with the actual value, that whether our model is accurate or not, how much it is accurate, and whether our estimation is correct to the is nearer to the actual value or not. So using those techniques, there are various modeling techniques are used, and one of them is the regression. Now, regression model is generally used for the continuous function, not for the discrete function. So we have a continuous data set, and with the help of those are not, because it is not a classification problem, it is a continuous analysis, continuous function, and the regression model is deals with the continuous function. So we have to establish the model, and we have to analyze it, whether how much our model which I established or I developed, how much it is accurate or not. So using this estimation, so regression, the linear regression model has its equation. What is the equation? Since it is linear, so the equation is a first degree equation, and it is given by y is equal to beta 0 plus beta 1 of x plus epsilon. So what are these parameters? Now, first of all, these, so we need, since the term is linear, we are using the term linear. So linear means that it signifies y is equal to mx plus c. So we can easily analyze the model is something related to the straight line function. So what are these parameters? So first of all, I will say what is y. Now y is basically a target variable. That means the target variable means the y is the actual value, right? Y is the actual value. So it is a target variable. That means when y is something is given certain value x equal to 0, right? So this beta 0 is basically an interception point of the y-axis, and beta 1 is basically the coefficient of x. So with the change of x, how much the y is changing, that is determined by beta 1, right? So I'm writing again. The equation is given as y is equal to beta 0 plus beta 1 x plus epsilon, where y is basically the target value, or we can say target variable. That means y is basically the actual value. Beta 0 is basically the interception. Interception on the y-axis, right? Now beta 1 is basically the coefficient of x. That means with the change of x, how much how much is y is changing, or how much the change of y is occurred. How much is the change of y is occurred? The change of y is occurred. So that is determined by beta 1. So how much the how much the with the change of the value of x, how much the change of y is occurred, that is determined by beta 1. Beta 0 is the interception on y-axis, and what is epsilon? Epsilon is nothing but a constant value. So if we see that I say,
Sir, your voice is coming slow, sir.
so this is basically two axes, and suppose this is the linear regression line, right? Now, so this point is my expected value this is my expected value of y at x equal to x0, right? So this is the specific, it is a specific value of x which is equal to x0. Suppose the specific value of x, so this is x, this is y. Suppose the specific value of x is over here is x0. So this line is basically our predicted line. Predicted line, right? So, so this line equation, what I had said, y is equal to beta 0 plus beta 1 x plus epsilon. Right? So if I draw this dotted line over here and I want to make a slope, so what this slope of line beta 1 and this is beta 0. So this is with 1 unit change of x, how much is y is changing? This beta 1 signifies over here, right? If I make a slope of line over here, and if I continue this, if I want to measure, then I will see that how much with 1 unit change of x, how much the y is changing, I can able to determine, right? So this is my expected value, and if this is if I draw a projection over here in this line of regression, right? So I will analyze how much error has occurred, how much error will be occurred. So this is just a pictorial representation of observation of the predicted of a regression model. Now there are now how the error is calculated. The error is calculated uh, the error is calculated by, for any model, the error is calculated by the actual value, my actual value, that is the y, minus my predicted value, that is the predictor, actual minus predictor, that is the our x, right? So this is basically the error is calculated. So if the predicted value is very closer to the actual value, and if the error is negligible, then the model is perfect.
So your voice is not clear, sir.
Is it audible now?
Yes, sir.
No. Now I'm writing a code import numpy as np. Again, import pandas as pd. Import matplotlib matplotlib dot pyplot pyplot as now from google dot collab from google dot collab import import files upload equal to files dot upload. right? I'm choosing the file. Now I will write df dot df equal to pd dot read underscore csv, and I will just copy and paste over here. Now I will say df dot head, df dot head, my file is imported. So if I say df dot head with the first 20 values, then, and if I run it, I will get the first 20 values. Now, if I say how many columns in the data frame, then I will say df dot columns So these are basically the columns in my data set, right? So, and if I want to visualize the my data set, I will write plt dot scatter plt dot scatter in the bracket. I have to write all the columns before that. Uh, then I have to make the bracket to identify with respect of all the scatter diagram with respect to columns. So df have to make a bracket to write df over here. My square bracket starts and ends. df suppose can do in this way. Suppose I want to visualize only the two columns. Data type equal to the object. The first bracket. See whether we visualize this. So this is a scatter diagram of the two columns, X and Y. So if I want to, so I'm comparing the pregnancy and glucose, the two columns, and the data types is given like this. So using this matplotlib function. So this is data visualization of using the two predictor variable, right? So if I see the data set, so this is the data set, right?
Sir,
Sorry,
Sangram, I want to ask you, sir, that can you please show us the previous coding just now that you have entered?
yes. Mm, mm, yes. Now, so this is a data set of, this is a scatter diagram of the two predictor variable. Now, if I want to show the scatter diagram between one predictor variable and the target variable. Suppose I want to show the scatter diagram of one predictor variable and one of the target variable. Suppose the outcome. Right. Just a minute. Scatter. Comma. Yes. Right. So, this is basically the scatter diagram of one predictor variable and the target variable. So in this way, these two lines over here shows this is a predictor variable and this is the target variable. The data set is arranged like this. That is why the the data visualization between the predictor and the target variable is looking like this. So this is basically nothing but a data visualization of my given data set. Now, if I want to see the information from my data set, what I will write, data.info. I will get all the information from my data set. Sorry, it would be df. My data set name is df. So this is the information, all the information of my data set. That is the information of what is the data type and the data type of the break of the various columns and other information. So these information are coming from the class pandas.code because the pandas is basically a library which is defined in a class, and the frame pandas.code pandas.code.frame dot data frame. This data frame is basically an object. Frame is a class, and code code is basically the object of the library function pandas. So from here, so all of these are defined in a class which is demarcated by the delimiters, and these are the data types. What are the data type which is defined over here? So this is all the information of my data set. Next, we move to if I want to see the description of my data, what I will write, df dot describe. I will get all my description of my data set. Right now, this count description means this describe function is basically has a statistical significance of the data set. That is the statistical minimum. So this describe function basically gives the statistical measurement of the data of my given data set. That is what will be my mean value. So mean value of the pregnancies is calculated. The mean value of glucose is calculated with respect to each of the my attribute or columns. The mean value of the skin is also skin thickness is calculated. Insulin is calculated. Similarly, this standard deviation of the pregnancy is also calculated. Glucose is also calculated, and so on. The minimum value and the maximum value is also calculated. Now, accuracy of 25% accuracy, 50%, how it is accurated with the actual value, and the mean how the predicted value is calculated with the actual and the mean value. That has been calculated by different percentage parameters, that is 25, 50, and 75. Right. So this is what the describe is. The describe function gives the statistical measurement of the data set. Now, if I want to get or prepare the data from the data set, if I want to see the data from my data set, what will I write? X equal to df.
Your voice is not clear, sir.
We will write df dot ilog ilog taking consideration of the whole data set, comma, starts with the 0th column and dot values. Right now, after that, if I want to get the set of array, so these are the datas of the 0th column from my data set. So converting all the observation of the 0th column into a numpy array. So this 0 means 0th column. That means my index value with 0, taking the consideration of the whole data set. The 0th column on the datas are present, so in the numpy array in the form of
What is meant by ilogs?
ilog is basically a function which is used for preparing a data set. If I want to use a data set, I have to use this ilog function, and iloc function when I is basically when I use to measure the, if I want to take the consideration of the 0th column, when I want to take the consideration of the certain column, I have to use this iloc function. If I want to see the first column, all the data of the first column, I have to use this iloc function. And iloc, before use this iloc function, I have to use all, I will take the consideration of the whole data set. I have to write in this way. This double colon means I'm considering the whole data set, and then I am taking the name of the column. That is, it may be 0th column, it may be first column, that is the column, the index value of the column. And if I write the values, all the values of that particular column will be displayed. Similarly, if I want to see the target variable, the values of the target variable, so I have to write y is equal to df dot ilog taking consideration of the whole data set from the first column, and then write y. So this is the target values. So we know that there are two things. One is building the model, another is testing the model. So for building the model, we use train, and for evaluating the model, we use test. So testing is basically used for evaluating the model. That means I will test my model, my predicted value, with my actual value. That is evaluating the model. And for building the model, I have to use the train set. So train set is basically used for building the model, and for evaluating the model, we use the test set. So test set is basically used for evaluating the model. So in that respect, I have to use from sklearn, from sklearn dot model selection import model selection, import train underscore test dot split, right? So x underscore train comma x underscore test comma y underscore train y underscore test equal to train underscore test dot split, and within the argument we'll write x comma y comma test size test underscore size suppose equal to 0.2 comma random state equal to 0. Now I go here x x underscore chain x underscore train dot I say shape from a sklearn dot model selection import train test dot split. No. If I say that x x underscore train comma x underscore test comma y underscore train comma y underscore test equal to train test equal to split. If I write x comma train underscore test dot split, then x comma y comma test underscore size which is equal to 0.3 comma random state equal to 0.
So I think you skip the underscore in random state.
Sorry. So to that x underscore train Yes. So from the sklearn.model selection, so sklearn model selection, for model selection, we use the one of the library named sklearn. So from there we import the training set and test set and then split it into two set. One is for building the model, another is for evaluating the model. So we use import underscore train dot underscore split, and we use the x, all the x variables, that is the predictor, that is the glucose, the other predicted values, that is pregnancy, blood pressure, skin thickness, these are all x. That is all the predicted values are assigned as x, and we take those values randomly. We took all those values, all those columns and their values randomly, and we then want to test those values. So we took all the values from the respective column randomly, and that is used for train, and then we want to test those values, that is for the x test. At the same time, as it is applicable in the predictor variable, as the similar thing is applicable to the target variable. We choose all the random values of y, and then we test those values, and then we are splitting into the two parts, that is one for building, another for evaluating the model. So we use train underscore test underscore split function, and we are splitting both the two bivariate variables, that is x and y, keeping the test size is for 30% of the test size and 70% for building the model. So we are evaluating up to 30%, and for rest values are used for building the model. So 70 and 30. And the random state equal to 0, that means random state means to stabilize the model. For stability the model, for stabilizing the model, we use a random variable of 0, right? Otherwise the random variable will fluctuate constantly. That which is, it may be, in order you can give any of to make the model stabilize, you can use any values, but it will be preferred that if you use zeros and one, right? So for stabilizing the model, we use this random state, and we use, and generally we use the 0 value. So if all these figures are used for building the model, so for evaluating the model, for evaluating the x value, we use x underscore test. These numbers are used for testing. So if I want to see the dimension, if I want to see the dimension of the test size, what will I will write x y dot test dot shape. Right, just a minute. Hmm. Means y underscore test dot get function. So this is the dimension. How many values of the target variable has. Right. So have you understood these things?
Hello, sir.
Mm.
Sir, the first coding, sir. The importation part, sir. When you import the file, sir. Yes, sir. Sir, here you choose the file diabetes.csv. That is, sir, in your local PC, that data set, or you upload it from internet.
Yeah, I got it from the internet.
Oh,
There
okay.
are lots of data set which are available in Kaggle,
Yeah,
right?
yeah.
You can also download it from the Kaggle and you can uh, build a model.
Okay, sir. Okay.
Sir, I have a question, sir. What is the X train and Y train here? It is Y two train we have chosen, sir.
Train and test. Now for there in machine learning, these two things are very important. That is for training, there are one set data set that is which is used for training, and there is another data set which is used for testing. Now the training part of the data set is used the randomly for building the model, right? If I want to build a regression model, linear regression model, I have been asked to build a data set is given to me, and I have been asked to build a linear regression model, right? So how should I build that algorithm, right? So in order to build that particular algorithm, I have to use with the help of the data set, I can able to build that particular model or the algorithm, and the algorithm is built with the help of the data set. Now the training set is used for building the models, for building the algorithm. Now this training uh, data set is used, the data are used randomly, the data are collected randomly from the data set. The data set are collected randomly and it is chosen randomly for building a certain model. That is, it may be a linear regression, it may be or any other non-linear regression too. So For building any linear or nonlinear model, I have to utilize a data set, and it is built in automatically. And uh, in order to evaluate that particular model, in order to whether that particular model is working properly or how much that particular model is accurate with the actual value, that is being determined by the testing or test set. So for building the model, we use the training set, and for evaluating the model, that is how much that particular values are accurate with the actual value. That is the value which I had calculated manually. That is my actual value, and the values which I had received through coding. That is how much that value is nearer to is how much that value is accurate with the actual value. It may be nearer to the actual value. It may be may not be the nearer to the actual value. That is, the values may be deviated. So how much it is nearer to the actual value, how much is our model is accurate, that is been testified by this test set. So for building the model, we use this training set, and for evaluating the model, we use the test set.
So, sir, in this data frame, what will be the actual value?
This is the actual value, right? These are my predicted value. These are all predicted value. Now the actual values is basically a dichotomous in nature, right? So I had
My
to
screen
make
is not.
this. A dichotomous means that is it is a classification problem, that is the classification analysis, that is the actual values are basically contains ones and zeros, right? So if these parameters permit, I assign it as 1. If these parameters are there, I assign it as 0. So these assignment is done by me, and it is done randomly. These one and zeros assignment are done randomly,
So your screen is not visible.
right? Yes, any question? Yeah, yes. Sir. Now these ones and yes, so these one and zeros are made randomly. It is not that these 10, 168, 74, 38.537, 34. Yeah, if these are assigned, it is
Your
minus.
screen is not visible.
Is it? It is not visible. Is it visible? Is it visible?
Yes, sir, visible.
So these are basic. So this column is basically the actual value. These are my all predicted values. And these ones and zeros are made randomly, not taking any measurement from over here. Right? Not taking any measure. See, the this column is also arranged, the numbers are arranged randomly, not in a sequential order. Right. So you today just go through up to this, and in the next class I will show you how to create the linear regression model and how to fit that particular model into the linear regression, right? And then I will evaluate that particular model with the actual, and I will calculate my the predicted value with that actual value. I will show those things in the next class. At the same time, I will do people go through the pandas material which I had given to you.
Yes, sir.
Completed that material.
Yes, sir, a little bit. The last statistical part is not completed.
Okay. So I will also go those through pandas. I will complete the panda and then I will return to this machine learning. So the next class will be on Wednesday, right? So before that, you go through these things. You can go to another thing is that mm, there is mm, you can go name. You can go to the site sklearn or you can go in uh, the name is the scikit-learn. Scikit-learn regression linear regression model. You go to the Google and write these things. You will get a material article of linear regression. Right. You read that particular article. Everything is given over here. Right. So I will also explain. I will explain the linear regression. And in the next class, I will create a linear regression model and I will fit that particular data set into a regression model. And after that, we will evaluate that particular model, right? So that will be done on the next class. At the same time, I will do the pandas, right? Okay, that's all today.
Sir, Hello, sir.
Okay, I will share my previous code. Yes,
Sir, in last class you told to go through the statistical parts. Can you
yes.
please repeat what are the parts? You told?
The statistical part is that we are entering into the statistical analysis. We will go to when in the next class when I will do the pandas, we will see the statistical analysis. In the statistical analysis, you just go through the distribution, right? You just go through the redistribution and the if I want to build a certain and the regression. Only these two things.
Okay, sir. Okay, sir. Thank you.
Okay, fine. So we will meet again on Wednesday.
Okay, goodbye, sir.
Bye.
Sir, good night.
Good night.